Next, we're going to talk about exponential functions, which are another type of function that we'll be seeing a lot over the course of calculus. So what is an exponential function? Well, it is something that is of the form f of x equals a to the x, where a is some number. Now, if we want these functions to be well defined for all values of x, a must have certain properties, right? In particular, I will need to have that a is greater than 0 for this function to make sense for all values of x. And why is that? Well, for instance, if I want this to work for all x, I want it to work for x equals 1/2. In that case, at 1/2, this function, f of 1/2, will evaluate to a to the 1/2, or the square root of a. Therefore, if a is negative, this is not defined. And on the other hand, for x equals -1, f of -1 is 1 over a, which is not defined at a equals 0. So for this function to be defined for all x, I must have a being some positive number. Now, what do these graphs look like? Well, there are two sort of main options here depending on what a is. One thing we know for sure, though, for any function of the form f of x equals a to the x, what is f of 0? F of 0 is going to be a to the 0. That's 1. So no matter what, I know that this graph is going to cross through the point 0, 1 right here. And what does the beyond that depends on what the value of a is. So if a is bigger than 1, we'll get a graph that sort of starts down here, comes up and goes through like that. If we have a less than 1, we get a graph that goes the other way. Right? Because for a less than 1, taking more powers of a, making x bigger, makes the result smaller. Because you're taking more and more powers of, say, 1/2, 1/4, 1/8, it gets smaller as it goes. That's going to be a graph that starts up here, comes down this way, goes to the same point, and goes through. And what happens for a equals 1? Well, I just get 1 to the x, which is 1 for all x. So I just get the straight line through the middle. That's sort of the anomalous case. We ignore that one usually. We're looking at the two options here of the exponential increase or exponential decrease for these graphs. Now, beyond these functions, these graphs, we can talk briefly about rules for exponents. So main things for these rules to keep in mind are this is how you can manipulate exponential functions and just expressions involving exponentials, simplify things out. So this is things like if I take, say, a to the x times a to the y for the same base a. Right, in this case, a is referred to as the base of the expression. This becomes a to the x plus y. If I have a to the x raised to the y, so nested exponentials here, that becomes a to the x times y. If I have two different bases put together, so a times b to the x, I can split this up as a to the x times b to the x. And the same goes for fractions. So a over b to the x is a to the x over b to the x. In particular, things like, b to the -1 is 1 over b allows that also to work out in that way. The key thing to realize, these two do not work for addition and subtraction. That is, a plus b to the x is not equal to a to the x plus b to the x. At least not for all x. It'll work for 1, and that's about it. So the point is, if I take, say, x equaling 2, that's squared, and I will have that cross term in there, the 2ab term from squaring out the binomial. So this does not work, and the same goes for subtraction. A minus b to the x is not equal to a to the x minus b to the x. Please do not make these mistakes. Those are not true statements. You can also use these rules to help you solve exponential equations for a variable that's hidden in them, and that's just by applying these rules in various orders to simplify out what this looks like, mainly because we know that these functions are what are called one-to-one functions, in the sense that if I know that a to the x equals a to the y for the same base a, this means that x equals y. There is another way to make this work besides having x equals y. You can also think about this as taking a log. If you've seen that before, we'll talk about logs in a little bit. But if I can get them so the bases match, then I know the exponents must also match, and that lets me solve out these equations.